Hello everyone, I welcome you all to this class. This is mathematics class, and we introduced the concept of ordinary differential equation in our previous video. And today we want to look at the subtopic formation of ODEs. So let's know how we can form ODEs from a given um, equation. So the ODE is just a short form of ordinary differential equation. Now, if you want to form an ODE from a given equation, now that equation that will be given to you, we have what we call arbitrary constants. Arbitrary constants. Now, if that equation is given to you, you are going to differentiate that equation. That's all these things I wrote down on the board here. Is that if an equation, if a differential, sorry, if an equation is given to you, all this thing I wrote on the board here is that if an equation is given to you and that equation involves arbitrary constant or arbitrary constants, now you want to form an ODE from that given equation. So what you are going to do is just to differentiate that equation up to the number of times of the arbitrary constants appearing. So if you have two arbitrary constants, you differentiate the given equation two times. If you have three arbitrary constants, you differentiate the given equation three times. And after your differentiation, you are going to write the result in terms of the dependent variable and its derivative. You write the equation in terms of what? The dependent variable and its derivative. Then that result will give you what? Your ODE you are looking for. So we have this example to consider. They ask us to form the ODE of the equation y is equals to a exponential 2t plus b exponential negative t. These a and b are arbitrary constants where a and b are arbitrary constants. So a and b are arbitrary constants, and we want to form ODE of this. We want to form ODE of this equation. Now, how many arbitrary constants do you have? Two. Now, if you are going to differentiate this in two times, so let's proceed. Solution. So we have two arbitrary constants. We are given that y is equals to a exponential 2t plus b exponential negative t. Now, in this equation, y is the dependent variable, right? Y depends on what? T. T is independent. So it means that after differentiating this equation two times, because we have two arbitrary constants, you are going to write the result in terms of what? Y, which is the dependent variable, and its derivative, right? So dy dt will be equal to what? If let's differentiate the first time, dy dt will be equal to what? You know how to differentiate exponential, right? Differentiate what is on the exponential, differentiate 2t, you get what? 2. You multiply it by use the result to multiply the exponential, you have 2a exponential 2t, right? Then if you come here, what is on the exponential is what? Negative t. If you differentiate negative t, you get negative 1. Use the negative 1 to multiply what? The exponential. Because we have positive here, if you use the negative to multiply positive, you get what? Negative. You have negative b exponential negative t. So you are going to differentiate this the second time, because we have two arbitrary constants. Second derivative of y with respect to t. This one I wrote is the second derivative, right? And differentiate the second time. So this will be equal to what? If you come here, differentiate the exponential, what is on the exponential is 2t, differentiate 2t, you get what? 2, multiply, use it to multiply this exponential function you have. You now have 2 multiplied 2 is what? 4. You have 4a exponential 2t If you come here, what's an exponential is negative t. If you differentiate negative t, you get negative 1. Use to multiply the exponential you have. Because what you have here is negative. Negative multiply negative, you have positive. You have positive b exponential negative t. Right? Now, I will call this first equation I have equation 1, and call this one equation 2, and call this one equation 3. So what I'm going to do is that I'll write my result in terms of what? In terms of y, and permit me to write this dy dt in short form like this, y prime, and this second derivative of y with respect to t, let me write it in short form, y prime prime, using Roman numeral, right? So I'm going to write this equation in terms of y prime, and y prime prime. That's in terms of dependent variable and its derivative. So how will I be able to do that? I will try to know if I can relate the equation, right? I will try to know if I can relate this. So if you watch closely, if I add equation 2 and equation 1, this term and this term will go, right? I will now have this and this. So let us do that. If you add equation 1 and 2, this implies what? We add this. If you add equation 1 and 2, you will now have, let's add the left side first. Y adding to, you add y and y prime, you have y plus y prime equal to, you add the right hand side. If you add b exponential negative t and negative b exponential negative t, this one and this one will cancel, because here is positive, here is negative. This one will cancel. If you add this one, 2a exponential 2t and the a exponential 2t, you get what? 3a exponential what? 2t. I'll call this equation what? Equation 4. Next one, I'm going to relate this last one with equation 2. Why I'm relating it to equation 2 is that if I do that, this one can go. B exponential negative t. If I add it to negative b exponential negative t, both of them will be 0, right? Then I will now have this plus this and this plus this. So let me add quickly. Add equation 2 and 3. So if you add equation 2 and 3, let's add the left hand side. You now have y prime prime plus y prime equal to, I've added the left hand side, add the right hand side. If you add this and this, you get 0. Then add 4a exponential 2t and 2a exponential 2t, you get 6a exponential what? 2t. This is what you are going to get, right? Okay. Now I'm going to this equation now. This equation I got here, I'm going to relate it with this equation I got here, this equation 4. You can see that this equation, this one I got now, is a multiple. It's a multiple of equation 4, because 6a exponential 2t, you can write it as what? 2 times 3a exponential what? 2t. But what is 3a exponential 2t? 3a exponential 2t is the same thing as y plus y prime. Remember our results now, after differentiating, I told you write your results in terms of what? The dependent variable and its derivative. That's what we are trying to do now. Now this one we got 6a exponential 2t is the same thing as 2 times 3a exponential 2t. But 3a exponential 2t is y plus y prime. So this will be equal to 2 multiplying y plus what? Y prime, right? And if you open the bracket, you will now have what? 2 multiply y is 2y, plus 2 multiply y prime is what? 2y prime, right? So this simply implies, what do you have at your left? Y prime prime plus y prime is equal to what you have at your right? 2y plus 2y prime, right? So collect everything to your left hand side. this implies y prime prime plus y prime, right? Then if you move everything to your left hand side, you will now have negative, let's move this one first, negative 2y prime. If you move this one to the left, you change the negative, negative 2y, then nothing is remaining at the right hand side, 0, right? So this implies what? Y prime prime, y prime minus 2y prime will give you negative y prime, then minus 2y equal to 0. So with this we have formed the ODE. We have formed the ODE associated with this given equation. So let's consider example 2. They asked us to form the ODE. ODE is ordinary differential equation. Form the ODE of the equation y is equals to a cosine of mt plus b, where a and b are arbitrary constants. So you have two arbitrary constants, a and b. So, and if you have two arbitrary constants, you're supposed to differentiate the equation how many times? 2 times. And that will give you an ODE of what? Degree 2. So we are going to differentiate this. To form the ODE, I've written it down before, right? And I explain it. You have to do or differentiate up to the number of arbitrary constants you have. So we are given that y is equals to a cosine of mt plus b. Now, which one is the dependence variable? Y is the dependence variable, and which one is the independence variable? T. So y is the dependence variable, y depends on t. It means that for you to form this ODE, you are going to, since we have two arbitrary constants, you are going to differentiate this one 2 times, and the result after your differentiation, you are going to write your result in terms of what? The dependent variable, which is y, and is what? Derivative. So we are going to differentiate the first one. I will say is y prime. This y prime is what? First derivative. What is on y is, this is just denoting first. That's Roman numeral. This is Roman numeral notation. So I want to differentiate this the first time. So this will be equal to your chain rule, right? Chain rule or differentiation. You are going to differentiate what is inside, right? If you differentiate the angle of cosine, what do you get? If you differentiate mt plus b, remember you are differentiating with respect to t. If you differentiate b is a constant, they told you that b is arbitrary constant. If you differentiate b, you get 0. If you differentiate mt with respect to t, you get what? M, right? You get m. What do you normally do? You use that m to multiply. So you differentiate the inside, which we have done. We got m. That's m multiplying. You now differentiate the trig. Differentiate cosine. What will you get? Negative sign. You have negative a sine mt plus b, right? Which is what? Which is negative ma sine mt plus b. So this is the result we got, right? So the original equation we have, I'm going to call it equation 1, and this second one I'm going to call it what? Equation 2. So we just differentiated once. We are going to differentiate again, since we have two arbitrary constants. Y prime prime will be equal to what? We differentiate this again. So you come to this place, you do the derivative the second time. So as usual, you differentiate the angle of the trig, that's mt plus b. If you differentiate mt plus b, differentiate b, you get 0. Differentiate mt with respect to t, you are going to get what? M, as we have done earlier, right? then you are going to use the result to multiply. So you are going to get m. If you differentiate the inside, the angle, use it to multiply the result you are going to get when you differentiate what? The the trigonometry we have here is what? Sine. So if you differentiate sine, what will you get? Positive cosine. But have minus before here. So you are going to have minus a positive cosine of mt plus b. Right? So which you can write as negative, m squared a cosine of mt plus b. Right? I will now call this one what? Equation 3. But before I call it equation 3, let's see what we are going to have. Remember, I told you that after your differentiation, you are going to write the result in terms of what? The dependent variable and its derivative. So my result should be in terms of y, which is dependent variable, and its was derivative. Now, this is the original equation we have, right? This is the original equation we have. Now, if you come to this last equation, what is the relationship between? I told you are going to relate the equation, right? You are going to relate the equation of y prime and y prime prime, right? Now, what is the relationship between this one and this first one? Why I'm saying this because this one has cosine, right? The first one we had has what? Cosine. The only difference is that the first one does not have negative m squared, while this one, this second derivative is having negative m squared before a cosine mt plus bt. Right? So the only thing we notice here that the second derivative is equal to negative m squared multiplying your original equation y, because from here, from a cosine mt plus bt, from here will give you your original equation y. So from here it will be equal to what? Y. Right? So this implies what? That y prime prime is equal to negative m squared y. And if you bring this this one to the left hand side, this negative m squared y to the left hand side, you will have y prime prime plus m squared y. You now have 0 remaining at the right. So this, what is the order of this equation? 2. How many constants do you have? 2. So this is our required ODE. Remember, we did not consider y. We did not consider y prime because we note this is the result of the y prime. We notice that there is no relationship between y prime and y prime prime, y prime and y. And apart from that, this y prime prime and the y we related together with has given us the required ODE we are looking for. We are looking for an ODE of order what? 2, because we have 2 constants, 2 arbitrary constants. Since we have 2 arbitrary constants, we are expecting an ODE of order 2. And this, by relating this this second derivative and the original equation, we notice we got an ODE of order 2, right? So we have gotten the required ODE. We have gotten the required ODE.